I'm fundamentally convinced that for every single one of you in this room, your job will be impacted by AI within the next decade. And maybe that's not surprising anymore for those that have been following the previous talk. So we are in a period of change. And every morning, basically, when I open my news apps and read about the daily news, I read stories like this one. We are hearing or currently reading about stories of basically struggle of man against machine, and it's always portrayed as a lump sum game where a machine might actually be taking your job, and there's a lot of fear in this debate, because if you're a factory worker, nobody's going to ask you if you want further automation within your factory, or if you're paralegal, nobody's going to ask you if your law firm is going to introduce IBM Watson to screen legal documents. But it's also something that we witness this change also fundamentally in our own lives. And actually just bringing this down from the sort of big news and the big discussion about job disruptions and just thinking about how, as an example, your lives in your offices has changed in the past sort of years, I would like you to watch this movie and actually put up your hand if this looks like the office you first started working in. So the older people will put their hands earlier than the others. So basically, this is how my office actually looks like. My whole office I run my company from actually fits into my handbag. And if I think about my life, all of my transactions, everything I do virtually is digital. I buy tickets for the bus online. I buy most of my clothes, my books, even my groceries online. I do my transactions with basically sending money to friends, or all my bank transactions online. And I'm even walking around with this, so I'm actually tracking sort of the way I walk, the way I do all of my workouts, basically also figuring out sort of what's going on sort of with my health. So why am I even talking about this? Like, why does that even matter in a discussion about job disruptions? And it basically boils down to everything I do, all my digital transactions, all the sensors I carry around with me actually accumulate a vast amount of data. And basically 90% of the data that currently exists was created just in the past 2 years. And experts predict that data stored globally is now doubling every 18 months. So we're actually seeing an exponential explosion in the data that we have available. And that's all learning data. That basically is what it comes down to. And if we think about the last talk, for those of you that were seeing that one, I completely agree with Hendrik that data is actually the new oil. And along with data comes also a massive explosion in computing power. We're also on an exponential growth path when we're thinking about computing power. Just, I think it was 2 weeks ago, at Google's last developer conference, they actually also unveiled sort of their newest tensor processing units, and I have to read this number because for me actually it's just a big number. If they add, they can create TPU pods with 64 different TPUs, and those have a computing power of 11.5 petaflops of computing power. That's even a number that doesn't even mean anything to me. It's a huge number. So we're also seeing, along with the explosion in data, we're still seeing exponential growth in the computing power, and Google and NVIDIA are probably the sort of key contestants here. And along with basically the availability of data and computing power, we're also seeing a change in the accessibility of machine learning algorithms, and Henrik was also touching on that in his previous talk. So machine learning algorithms, through platforms like IBM Watson, through Google's TensorFlow, or through more independent platforms like Algorithmia, that's the one on the bottom, actually make machine learning accessible to a lot more people. You don't necessarily have to be a machine learning PhD anymore in order to use machine learning in your products and services. So I believe we're actually going to see a similar path with machine learning, or accessibility of machine learning, that we've seen in development or even web development, where you don't actually have to write all the code yourself anymore. There's going to be building blocks, and it's going to open up the whole field of machine learning to a vast, bigger group of people in that sense. And what does it all lead to? Those three things: data, explosion, the continuous exponential growth curve, and computing power, and then third, the accessibility of machine learning. It actually all leads to an exponential growth path when it comes to artificial intelligence. And artificial intelligence really has an incredible potential to disrupt jobs and to actually affect basically virtually every one of us and what we do on a daily basis. And there's often a lot of discussions about why do we even need to care. We've seen this in the past. Technological progress has always cannibalized and disrupted jobs. We've seen this in agriculture. This was the hot new shit back in the day. That's maybe not even the hot shit anymore these days. And also, if we think about production, this was a car production line in the old days. And now we have this car production line where there's virtually no human working in it anymore, at least not for the production line. And throughout these major technological disruptions, we still have always managed to create new jobs, and we haven't seen massive technological unemployment on at least at a continuous level. So when we compare the past, and now we're in this time, or in the beginning of this AI revolution, why do we even speak about job disruptions? Is there anything that's different this time? And I believe there's two fundamental differences. And the first one is the speed of automation, because effectively with those more exponential growth trajectories, we're actually seeing an incredible speed with which the impact of technological change is actually hitting us. And just a very fun example, the telephone took about 75 years to reach 50 million users. Angry Birds just took 35 days. And also, and actually one of the last questions was in the last discussion we've had here, was actually going into this direction, because the other main driver of a very different speed in this change we're witnessing now is that AI is actually accelerating the development of AI, because AIs can work on making AIs better. And this is also a very new piece of research that has been published by Google, and they've actually used an AI to actually build a better neural network. So we already right now are seeing companies working with AI to help build better AI. So it's another element that's accelerating this technological transformation. And the second point I was referring to, why this is different, is that we are now not only automating manual tasks, but we're increasingly automating complex cognitive tasks. So, for example, driving a car in an urban environment was considered something way too complex for automation just a few years ago. And now Google, or actually it's X, it's the moonshot factory of Google or Alphabet, is proving that they can actually have self-driving cars operating in urban environments, at least around the area around Mountain View. And so if you live there, and if you are there, you can actually see these little guys that you see there in the middle of all the sensor data. They're actually driving around there already. So what does that mean for job disruptions if we're now seeing a different speed and also different different tasks that are being impacted, because the latter one actually means that it's not only contained anymore, but it can virtually affect everyone. Let's talk about jobs or tasks at risk. There's an often quoted study by Carl Benedict Frey and Michael Osborne from the University of Oxford. They published this in 2013. It's called The Future of Employment. And basically, they were looking at different tasks and how prone they are to computerization. And they've reached the conclusion that for the US economy, 47% of jobs are actually prone to automation or computerization. 90% have a medium risk of computerization, and only 33% of jobs in the US economy actually have just have a low level of risk of computerization. And if we look at the right side, we can actually look into different sectors and what their outlook for different sectors is. And the sectors that they consider particularly prone to automation is actually it's transport, it's production, it's service-related tasks, and sales-related function, as well as administrative work. So what do they have in common? Generally, anything that's repetitive, be it a manual or a cognitive task, is facing a high risk of automation. So machines obviously excel at frequent high-volume tasks, and they also require a lot of learning data that you often have with tasks that are happening or are more repetitive. So what actually remains for us as humans? Like, where do we have a comparative advantage? I believe it's particularly tasks that comprise of something novel, that are complex and maybe complex and infrequent in that combination. And what we are very good at is actually learning from small data sizes or small learning sizes. At least most of us are pretty good at learning from small sample sizes. So the tasks that we that we have a comparative advantage at are tasks related to creativity, to social skills, to intuition, and to dexterity. And creativity, I would also include anything linked to very complex problem solving, to innovation. Those are comprised under creativity here. And also intuition, I would also include complex decision making that has very far-reaching ethical implications, for example. So those are the things that we have as humans a comparative advantage at doing, at least for now. And after now speaking about jobs at risks and maybe tasks more prone to automation and tasks that we as humans might be better at performing, let's dive into some more concrete examples here. So this is actually the autonomous car from Google. There's not even a steering wheel anymore. It's driving fully autonomously. And that's obviously technology that has a large potential to disrupt transport but also logistics, so to say. And maybe for this example and all the examples that are going to follow now, that's not science fiction. That's actually technology that's being tested out in the field right now, and it's all powered by AI. That's why I believe AI has this very there's a lot of talk about automation in general, but AI in particular has this very, very strong disrupting force. So transport and logistics, very, very prone to automation, probably not good news for the people actually currently working in this industry. And maybe just if you, after the end of this event today, would have the choice to either take a human-driven taxi to go to the airport or actually take an autonomous taxi to the airport now today, maybe with this car, who of you would actually rather choose the human versus the autonomous cab? Humans? Autonomous? No, it's half-half. I mean, statistically, for the applications they're designed for, they actually perform quite well. And if we are thinking about another sector that was mentioned by Osborne and Fry, that's sort of sales and service related, in this case in retail, how many of you have heard about Amazon Go? Let's watch it anyways, it's quite nice to see.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want.
So basically, very convenient for you as the shopper, but probably not good news for the cashiers. And moving from sort of sales related into production now. This is Baxter. Baxter is a robot that can actually work alongside humans. So it's also applicable in situations where sort of the traditional industrial robots that always have to be encaged cannot actually work in. So, and Baxter works for about the equivalent of $4 per hour without any leave days, without any sick days. So what does that mean for people working in production? And it's also powered by AI to be sort of context sensitive. And moving into an even more sort of traditional white-collar domain, we also see the application of artificial intelligence in the legal sector now, because there's an immense amount of sort of new laws, case-related documentation, legal documentation. So an AI can actually much better than a human read and understand all of those legal documents that are always being created, and can basically derive patterns and find the right things that are needed to prepare a certain trial. So what does that mean for the legal occupations? And finally, moving into medicine, we also see AI being applied in medical applications, in diagnostics in particular, and obviously also a field where there's immense amount of research data, of scientific papers that are being published. So an AI can very effectively read all of this, understand all of this, and maybe, as in this case, is particularly well suited to also figure out sort of diagnose rare disease, because there's not even a bias that might not even be an option because it's such a rare option in the end. So what does that mean for medical occupations? And I think what's quite interesting with these latter three examples, that's actually all technology that works sort of in a collaboration of AI and the human. So it's technology that's not going to completely get rid of entire jobs, but it's actually augmenting particular occupations. It's going to take away some of the tasks, but it's actually technology that for a large extent works well with humans, and it's going to augment some of what professionals in these occupations actually do. And then the final question that's always discussed is how quickly will these technologies actually disperse our world? Like, when are we actually going to see certain jobs, companies, or sectors impacted by these technologies? And that actually is a bit of a tricky question, because it's not only about technical feasibility, but it's also about economic feasibility, and also the big one, actually, regulation and social acceptance. So not everything that's technically feasible will be deployed immediately. And economic feasibility is basically the question, what's the productivity of the human versus the machine, and also the cost of the human versus the machine. And regulation actually massively impacts this sort of cost function as well. So let's talk about the availability of jobs. Like, are jobs going to disappear? Are we still going to work in the future? And I think it's always very important to, if you speak about that, actually define the time frame you're looking at. And a lot of articles and a lot of papers are incredibly fuzzy about the time dimension they're looking at. So let's, for now, decide that we're actually going to talk about the next decade, now from 2017 to 2027, what's going to happen. And I would actually like to hear your opinion first. And let's imagine we're thinking about Europe, and we're disregarding any effects of demographics. So we're just gonna figure out, we're just gonna see what you think. Are we gonna have more, less, or about the similar amount of jobs in about a decade? So you have to make up your mind, you have to put your hand up once. So who believes we're gonna have the similar amount of jobs in 2027? Who believes we're gonna have more jobs in 2027? And who believes we're going to have less jobs? Okay, so probably the majority of you said we're going to have a similar amount of jobs. Very few people believe we're going to have more jobs, and there are some more pessimistic people in this audience as well. So, as an economist, I could go into all these different scenarios now and think about different sort of factors and hypotheses and model of that, but that's a tiny bit boring, and we've seen that a lot of times. So from now on, I'm actually going to share with you my personal take on where I think we're heading. So bear that in mind. You don't have to agree with it. It's just sort of my take on this. I believe as we're hitting a period of more and more human-machine collaboration, we're going to see times where humans actually can, to some extent, focus on where they have a comparative advantage at, and machines are going to focus on what they have a comparative advantage is, and we're actually going to augment a lot of our capabilities with technology. I think there's a very good chance we're going to have the potential for similar or maybe even slightly raising amount of jobs. That's my personal take, and I'm going to share with you why I think that's the case. And I think when we talk about the availability of jobs, we're going to have to talk about these three things. We're going to have to talk about human-machine collaboration, the potential for more high-skilled jobs, and also inequality challenges. With the sort of last three examples I've shown you from Baxter, from sort of the legal assistant and applications of Watson in medicine, I believe there's a tremendous amount of work that's done in sort of bringing these technologies into the real world, training people to sort of work with them, but then also basically really engaging the work with these technologies. And I think there is a very big potential for a productivity boost out of the human-machine collaboration with this sort of very smart division of work. And just another example of actually also an AI startup in the Bay Area that are actually sort of real-time coaching sales agents to become better at sort of selling. And we're going to see, I think, a lot of AI coaching and augmentation for very different roles that actually has the potential also to actually bring up the income generating potential of those occupations. However, a lot of the jobs that are being created are very sort of high-skilled jobs. So we're seeing a world where people that are sort of digitally literate, that are adaptable, that are flexible to work alongside machine are actually going to have a very bright outlook. And so probably for most people in this room, that's good news. However, that also infers very strict or very strong inequality challenges because high-skilled talent is going to be even more in demand. We're probably going to be short of the people that actually can implement their technologies, that can roll out the technologies, that can work alongside these technologies. So these people are going to be in demand. But a lot of the people that have more sort of low or average skill levels, that's easier to be automated, that's faster at being disrupted, they're not going to be as much in demand. And they're actually going to be competing against each other in a hyper-connected world. They might actually even be competing against people in very different parts of the world. So So there's a massive inequality challenge that's hitting us in that regard. And why did I actually choose to focus on this 10-year time dimension? I think it's because we actually need to, that's, I think, a time span where we can think about solutions and how we actually want to design for these changes and how we want to shape sort of the future within this time span. And I initially said I believe there's going to be more potential for similar or even more jobs. However, I think I said potential because I think there might be demand for these people or for these skills, but that doesn't necessarily mean that there's also the ability to fill these roles. So in the end, how much unemployment we have and how many jobs we have doesn't only matter or isn't only determined by the sort of demand for skill, but it's also determined by the supply of skills or of talent. So another little sort of survey, who of you believes there's going to be enough qualified talent to actually fill the sort of jobs we're creating in 10 years? It's either yes or no. Who believes there's going to be enough adequately skilled talent for the roles we're going to be recruiting for in 10 years? Okay, and I guess who's against it? Who doesn't believe it? Okay, that's a very clear picture. So I guess we're all a bit pessimistic because I would probably side with the ones that raised their hands last. I believe we're heading for a potentially very large skill gap between sort of the skills that are needed to move from the old to the new economy. And I think that's actually one of the things we need to start doing something about right now. And that actually sort of, if you remember the title of my talk, that actually brings me to the second element. And I think especially when it comes to ability to fill jobs, we actually, AI can actually be part of the solution in many shapes and forms. And the first one is actually information distribution, because already today, we are seeing unemployment when we have jobs that need to be filled, and we have talent that's actually adequately skilled to fill these roles, but these two never actually find each other. So we have a distribution problem when it comes to automation and also to matching. And I think that's a very, very interesting one that you can actually address with technology and artificial intelligence in particular, because you can actually incredibly sort of improve the matching sort of potential of your job economy. So I think that's actually one of the aspects where artificial intelligence will be part of the solution to in the job market. And that's actually, not surprisingly, Google actually announced just also 2 or 3 weeks ago that they're actually moving into this domain. So they're using smart technology, intelligent technology, and AI to actually work on improving the sort of job search and job matching market. And actually, the other element is information discovery, because a lot of us aren't actually fully aware of the skills they actually have. You know which roles you've had in the past, but often you're not fully aware what that actually means on a skill level. And especially in a world where sort of roles and jobs are changing very quickly, you might read a job description, but you don't actually really know what it means. So helping individuals to figure out sort of their particular sort of skills and talents, and also matching them and helping them understand what sort of the skills and talents and experience needed for very, very new roles are, is another one where you can actually use artificial intelligence and predictive models who might actually transition from one career into another one very neatly. And the third one, or the second one, where artificial intelligence can be part of the solution is the whole world of learning and development. Because we can, with artificial intelligence and smart technologies, actually massively improve the personalization of learning resources. We can also make learning a lot more immersive. We can also trigger continuous learning in a much smarter way. So I think in this whole domain of learning and development, we're going to see a lot of sort of influence of artificial intelligence that can help bring people up to speed to sort of navigate this job disruption and times of change. And if we talk about learning and development. What are we actually sort of aiming for? What are the skills that we're still going to need sort of in the next decade? And I think there's one sort of meta skill above all, and that's adaptability. I think we have to learn and educate and teach sort of for adaptability. And sort of underlying that, it's not just adaptability, it's adaptability for me is sort of the flexibility to sort of jump into sort of new contexts, to also be flexible to work sort of alongside new technology. And sort of a basis for that often is a certain level of digital literacy. And the sort of the willingness and sort of the action to also keep continuously learning. Because as the technological change accelerates, as we've seen as it's happening in the sort of AI revolution, continuous learning is going to be the new paradigm of learning. Like the times when we started learning something sort of in the beginning of our career and we're sort of eating off that, I think are gone now, and we have to move to this continuous learning paradigm. And that basically means that as individuals, as organizations, and as countries, we have to act and we have to start shaping this future. As an individual, it's a matter of figuring out how you can become more adaptable, how you sort of also approach things maybe with a growth mindset, of taking sort of new technology and learning opportunities as a chance rather than sort of reflecting upon them with fear. And I think that's why the initial sort of discussion that I opened up with that we have often in media, where it's sort of like a man against machine sort of portray, is not necessarily helpful, because it leads to people sort of approaching this topic with fear rather than actually potentially also seeing the opportunity that lies within it. So as an individual, it's about learning and figuring out sort of your own approach to adaptability. And like, let's just, as an example, look at how the role of a designer might actually change in sort of the very near term.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now, with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
So imagine the potential of an AI-powered human designer. Like, with those new tools, you have a completely different sort of option space that you can sort of work on. And if we move into sort of what organizations can do, and I think that's an interesting one, because a lot of our work is still happening in organizations. So I think one of the key nucleus where some of this change actually needs to, or people need to be aided to actually navigate this change, is going to be in the space of organizations. And there's a ton of, or like, we have a very full toolkit of actually how organizations can help people to prepare for, to learn adaptability, to improve on sort of their knowledge of new technologies. And I think there's very basic concepts, very non-tech concepts that we've already seen in the past. GE, for example, already 2 decades ago, spearheaded the movement of reverse mentoring, where actually young employees mentor old employees, which plays a particularly big role in establishing digital literacy throughout an organization. But then there's also sort of tech and AI-enabled solutions. And I'm a bit sneaky, I'm actually putting in my own company here as an example. We're supporting organizations actually in redesigning the feedback and the learning cultures within organizations to really figure out what the underlying competencies of people are and navigate people through a process of continuous learning and upskilling. And another example I would like to include is actually from TNG, because I think you guys are really far in terms of like continuous learning in the workspace, because every employee at TNG is allowed to spend 10% of their work time on learning and adapting new skills. And I think that's something that's a lot of organizations are very far. Somehow we lost this. A lot of organizations are actually very far from dedicating that much time and resources to the learning and development of their employees. And then the last level is actually countries. And I think policymakers need to very carefully consider and shape the policies that also sort of spearhead and sort of help navigate this transition. And it starts in sort of the primary education sector, but it also that needs to be sort of redesigned. But it also means that there needs to be more incentives for continuous learning, even if you've already entered the workforce. And an interesting example in that context is actually Finland, because Finland is completely redesigning the curriculum of their sort of primary and secondary education system. Kids are no longer learning just very much sort of the typical subject-related classes anymore, but they're spending actually a lot more of their sort of learning time to actually work as teams on solving sort of problems in a very sort of collaborative and sort of open, complex problem-solving way. And I think that's sort of like where we need to move with sort of education system away from training people for sort of maximum efficiency to actually being sort of creative and adaptable for the changes to come. So to just, because that was a lot of points and I didn't have an agenda because I think it's nicer to just flow through a talk, I summarized some of what I think my main points are for you. First of all, I believe AI will impact most jobs, and sort of the AI revolution is driven by the exponential growth of data, of computing power, and of machine learning accessibility. The extent of automation driven by AI varies between roles and sectors. And what's striking is the change will be faster than in the past, and it's also because it's impacting cognitive tasks. It's also affecting a much broader sort of part of the economy and of society. The speed of full automation of certain tasks is very hard to determine because it doesn't only depend on technical feasibility, it also depends on the economic feasibility as well as regulation and social acceptance. Jobs will likely still be available for a couple of decades, but they demand very different skills. And high-skilled talent will be in high demand. However, low and average skilled talent will be hit much harder, so we really need to actually really think hard about the inequality challenges. And AI will help people to find new opportunities more effectively, and it will guide personalized continuous learning. So AI is not only part of the problem, it's actually a very powerful technology to build tons of interesting solutions to also help people navigate this change. And we really need to educate and develop people for adaptability and digital literacy, and continuous learning is becoming very clearly the new paradigm. Thank you. And I was actually trying to be very fast so we can also have a bit more for discussion and questions. So I hope you have a lot of questions or points, or you completely disagree with me. Happy to hear that.
Hi. First of all, thank you for this great talk. It was very interesting. I was wondering, you mentioned that the change we are we are observing right now, it's faster than in any decade, but there are also these voices that say it's actually not that fast as it seems. So like having a car, like coming from a horse to a car was a much higher step than now from a car to a self-driving car. So I was wondering, why do you think that it's faster, and are there any statistics or something that supports this hypothesis?
So first of all, I think that's actually a very, very, very good question that we need to address. I think what generally happens, especially with digital technology, especially now with AI, where there's such a buzz around it, like every startup in Berlin is telling you they're doing something with AI, even if they're not. And basically, I think the challenge is that we often completely overestimate the sort of immediate impact of disruptive technologies, but then we completely underestimate the sort of more long-term effect of these technologies. And I think that's something, if we sort of look into the past, for example, I've worked in the energy industry before with solar cells or PV cells. A lot of people were, like, there was all this buzz around the technology and people were expecting them to arrive super fast, and then it didn't happen as fast. And then everybody was like, oh, it's like they basically said, like, this technology is never gonna actually get anywhere. But then all of a sudden, like, through all these effects, we see a rather sort of exponential growth, and all of a sudden now, PV is incredibly competitive, and we have seen a rollout that's very much ahead of any of the sort of the market predictions by so-called experts. So I think we just need to be aware that probably for like the very short term, it's not going to be as massive as sort of like some of the current discussions suggest, but I think for the long term, we're completely underestimating the effects.
Well, maybe more of a comment, but you talked about inequality, and what I take away from your talk is that you're saying like highly skilled people will be the winner or like will profit from this. I'm just not sure if this will actually be the case, because the not so well educated people are actually the majority, and I mean the majority always has the influence in politics. And I think this is an issue one really should look at, that like nobody's left behind, because if people are left behind, they are gonna vote in a way which might not be that nice. I mean, I don't want to say Trump, but I'm saying Trump. Yeah. I mean, and yeah, so this is my comment. I don't know if you have expertise there or any suggestions what we can do there, but that's something we shouldn't lose focus on.
I fully agree. I think that's a bit of the paradox, right? Because I think there is a lot of benefit from a lot of these technologies. Also, when you think about, I mean, bringing education to all parts of the world, when you think about countering disease. But obviously, I think right now we're having a bit the movement that there's all these sort of technologists and people in Silicon Valley, for example, that are sort of like moving ahead, and they sometimes forget about the people that maybe also have to think about how to include them, how to also bring some of the benefits to sort of large majorities. So I think it's more the question of how do we make this work for everyone? And I think if we don't make this work for everyone, then we might very well see regulation that's actually very sort of anti-technology, and then maybe some of this will never actually happen. Any other questions?
So with a lot of people, as the previous questioner was asking, being in probably with low skills, as in the sense of your talk, I'm wondering, are there any ideas of new incentive systems different from money? My vision is that moving to a society where more and more people are probably unproductive in an economic sense, how can we, without moving to socialism, getting them or giving them an incentive to perform work which might not be productive in an economical sense, but still very valuable for society, like childcare, say, or care for elderly, all these things where you probably don't need so much technical skill, but which might be very profitable for society. But probably you cannot just pay them a large sum of money, which they might deserve for what they do, but it's economical, probably not feasible. Are there ideas in these communities?
So, I mean, actually, maybe one remark to that is, I think probably a lot of you actually noticed that I never spoke about universal basic income, right? Which is often one concept that's actually discussed in how do you make this work for more people. However, I'm sometimes a bit reluctant to speak about universal basic income because I think the danger is that people are saying like, oh yeah, we have universal basic income, check, like it's solved for everyone. And I think that's really sort of not the case because a job, and there's a lot of research of that, actually at the University of Oxford, a lot of people are also looking into that a job is not just sort of, does not just have the function to earn someone an income. Like it gives people identity, it's incredibly important sort of for the identity of a person, for a community. So I think we do need to figure out sort of what concepts around sort of sharing opportunity and sort of as one aspect of that also helping people to sort of have the means to live. We need to figure out how to design for that. But I think it's not only a question of income, but it's also a question of actually equal distribution of opportunity in a wider sense. And I think that's why I actually chose to speak about just about the next decade, because I think these questions become really interesting if you're looking further into the future than a decade, right? When you actually have a very high potential to even automate even a lot more of what still will probably be done by humans within 10 years. But I think my general take on that is, I think as humans, we actually have sort of a demand to create things, to shape things, to build things. And I think we're still a human-centric society, even if it's powered by technology. And I think if having the opportunity to work, whether that's paid or unpaid, is a human need, then I think we're going to find ways to sort of supply this opportunity to sort of also larger amounts of people. I don't know if that's my personal take. I don't know if that answers your question, and maybe that's also a very economist answer. Great, I think. Any more questions, or do you want to, I don't know, have coffee?
There may be as a last question, a slight deviation from your main topic. Namely, what do you think on a coexistence of a human and machine economy as an economist? So, I mean, I think the most lucid idea I've heard about is that we can all imagine having driverless cars that are self-sustained, have a self-sustained economy. So they're paid in some digital currency, they go get electricity, they go to the shop if they need to get fixed, and they just have a self-sustained economy alongside our economy. What do you think about that?
I think there's a very compelling concepts, and actually there's a very cool company working on this out of Stanford that's called Regen Villages, and they're actually implementing their first pilot in the Netherlands, I think, now in the coming years, where they're creating a completely self-sustaining community with hydroponics, like so they're growing, sort of have their own vertical farming, they generate their own sort of electricity, their own food. I think they have a closed loop with the water they're using. And I think there's a lot of interesting experiments and pilots and sort of prototyping around that. So I think, yeah, that's an interesting opportunities around that. And maybe linking to the last question, I think potentially also what we're going to see a bit further into the distance is more sort of a long tail economy where everything that's sort of like about productivity is going to be done by machines. But things that are more like creative, like craftsmanship, like coaches, like experiences are going to be things that are ultimately human and create opportunity for humans. So we're going to see the sort of the big productive part done by machines, but then we're going to have this massive long tail of sort of human interaction. Maybe some of that is going to evolve around sort of sustainable, sort of closed communities. Perfect. Yeah, great questions. Thank you. One more. You're the masters of time.
Yeah, we can have one more question.
I think there's one right over here.
There are some classical methods how to judge people or employees. You want to hire someone, so the best classical method I've seen was a web-based procedure where you answer up to, it was I think 200 questions. with AI, I would suspect that you're able to run automated procedures much better than with classical fixed questions. And the method I used once was from Recruitema. It's available in 8 languages. What is the latest development in this respect, judging people, or people you want to hire?
I mean, I think the classic example that's now been portrayed so much in the press is actually the Cambridge Analytics example, right? When from social media data, just from social media data, researchers developed sort of an algorithm that could actually predict sort of the big psychological traits of individual people, and that can be used for all sorts of applications in marketing, but also obviously in hiring. I think, yes, we are able to much better sort of predict if somebody fits a particular role based on probably just publicly available material or like data on that person. And then obviously also when a person enters the workspace, there's going to be a lot more data that can be used to also measure how productive a person is in a particular work environment. The latter one, I think, is actually quite a dangerous one, right? Because that's also has the potential to also increase sort of the inequality of income distribution within a company, because all of a sudden I know who actually generates sort of what value within my company. So like measuring everything ahead of sort of hiring, and then sort of while you have someone within your company can sort of be beneficial, but also actually needs to be, there's a lot of ethical considerations around that as well. Sort of that's a bit of a loop on your question.
Okay, I think we'll stop here. Thank you again for your interesting talk.